everybody, it's SHAZIZZ here. What you're looking at there is a tattoo gun motor and a fluorescent bulb. This video might be a little noisy and obnoxious, but I think it's got a really good, interesting thing that I'd like to share with you. Anyway, what I got here is a 120 volt AC adapter to 12 volt DC at 1 amp. Alright, and I'm using this to run that tattoo gun motor there. So this is where the point where it gets a little bit loud and obnoxious, so just want to show you a couple things here. Alright, now we got the tattoo gun running. You see this fluorescent bulb over here. Putting some body heat to it, so I don't have to get up and turn the light off. Alright, well, you know, that's pretty cool. Not really all that impressive, but there's a reason why I want to show you this. Now I gotta reposition the camera. Do. Good old repositioning of the camera. Loosen that up. Bring this up. And bring that down. Okay, so now what do we have here? Now we got a tattoo gun, a fluorescent bulb, an electric motor out of a electric fan motor out of a microwave oven. Not sure the volt range. I'm sure is around about 120, 60 hertz, but I'm not sure anything more than that, how many watts or anything like that it takes. And what we have over here is a transformer out of one of the old APCs or UPCs or whatever, the battery backups. And we got a voltmeter. I've got a little light bulb on here that will not come on, and that's alright because I'll explain that in a minute. Anyway, this particular transformer has 3 wires that comes out, and I've got right now I've got the black and the red one running over. Let's follow them here. Okay, this red one right here is running down to the positive side of my power supply. The yellow one, which is connected to the white wire, is running over to one side of the fluorescent bulb. Doggone nag screen on Panda again. And the black wire is running from that black wire on the transformer over to the opposite side of the fluorescent bulb. And the wires for the electric motor are running on each end of the fluorescent bulb. Now let's fire this thing up one more time. Let me see if I can get a little bit more height on this, because I want to try to get that, that doggone voltmeter in there too. Let's see what we do here. Haha! It looks like it just might do it. Let me lock that down. Sorry about the obnoxious video there. Alright, so let's plug this thing in again. Now what we're doing is we are literally pulsing the doggone tattoo motor. And if you notice down there, there's a spark going on. And I shocked the living dog snot out of myself because I touched that section and that section at the same exact time, which wasn't pleasant. And so with that said, don't do it. Don't learn electrical safety by accident. So essentially we got pulse DC going on here that's actually turning that motor right there. And if you notice over here, we have about anywhere from 70 to a couple hundred, up to about 400 volts fluctuating on the deal, but you can obviously see that there's no current because that light bulb isn't lit up, and it's connected right in with parallel with that voltmeter. But you can see that that is actually sending the signal out. And what I failed to mention earlier, if you look on that electric motor, you'll see that there's some extra windings on there, and I'm not even sure the gauge of it. I just fit as much as I could right over the top of the primary coil on that motor, and was trying to see if I can pull energy off of that motor. Now, if you use some really good magnet wire and did it properly, you'd probably get better results than what I'm getting. So I didn't expect really good results. I just wanted to see if I could collect some of that extra energy coming off. However, you can see right there from that light bulb not lighting up that it's not very impressive. But yet, you're still pulling some off. Now, the cool thing about this tattoo gun is, first off, this isn't connected tightly on there. I just got it basically sitting there close because I don't want a direct connection. I want that spark in between there. I should have took the time to actually build some sort of spark gap for that. And you can see where when these coils are vibrating, it goes back and forth from this coil, sucking the electromagnetism, sucking that rod back and forth down, and causing it to arc across there. But you can actually tune this thing if you're careful. Let me do this without shocking the crud out of myself. If you do this, hold on to an insulated part and then unscrew this screw. Otherwise, you're going to shock the crud out of yourself. Now see, you can slow it down, speed it up. I normally look to see where that bulb is lighting up good. Lost my connection. Alright, come on now. Once you get it where you want it, I don't know if you can even see that light going. Let me try hitting it. See if I can do this in the dark. Get the shot. Alright, I'm gonna attempt to try to tune this while it's while the light's off. If you get it just right. Oh, somewhere in that range would have been nice. I'm having some dilemmas here. Alright, I'm going to pause this so that I can get this video mixed right. Hold on a second. Alright, apologize for that. What I wanted you to see, that I don't know if it's going to happen here because things just never seem to work out like they did before. Let me see if I can get this. I might have to take the camera off and float into it. Meantime, I wanted to get that. I'm gonna turn the light off one last time. Tried to adjust this while it was in the dark, but I wasn't doing so well. But actually, you get it right where you want it, and that light to be really bright. I want you to see that spark gap right there. When this coil is fluctuating off and on, every so often you'll get a flaming arc on that thing, where it builds up a lot of power, and essentially you're just making and breaking the circuit. Even on this side over here where, I better turn the light back on. I'm going to mess around and get shocked again. And it hurt too. Anyway, spark gap on this side. Because this isn't it's just barely touching on there. That's what you want it to do. Let's see if I can do this again. Oh, there we go. I'll hold it steady long enough. Now you can see it. A little bit of arc going across there. That's what you want. And that's starting to jack with the camera. Alright, so essentially created a pulse DC circuit with a tattoo gun. Pulsing that little transformer, and in all reality inside there is also pulsing. Whenever you tap the power on, it's when you let it off, it's a really strong pulse. Now back to this over here, what I was saying earlier about reason that bulb ain't going on. I'm getting some frequency going through there, so I'm probably, because of this voltmeter, probably just getting a bum reading, but you can see where it's actually going up there pretty high. So I'm going to keep doing some experiments with that, but essentially I got a secondary coil wound right around the primary coil on that electric motor, just so I could see if I could drag some off. And so with that said, if you try this experiment with a tattoo gun, remember, don't touch these two parts at the same time, or these two parts at the same time, because it hurts and it'll lay you out. Alright, well, if this was done right and tuned right, you should be able to get better results than what I'm getting right here. But I'm running this little fluorescent bulb here intermittently. If it's grounded right, it'll do better. And I'm running that electric fan there off of this tattoo gun with that little 12 volt 12 volt to 1 amp power supply. Alright, take care everybody, people. Peace and love. Hello everybody, it's me again. One more little short addendum. I wanted to show you something here. This is the microwave light bulb. I'm not even sure what the wattage is on there. Sure, we could find out if you needed to know, but wanted to show you something here. Let me fire this thing back up. Right now that is just that's just running directly into that secondary that I wound right there. Okay, now I'm going to hope you can see this, and I'm going to hope I don't shock the crud out of myself, but keep your eye on that light bulb. you can see that lighting up and the fan's still moving. Doggone it, hold still there. Chive turkey. Okay, let me, not sure if you can see that just yet, so I'm going to turn the light off and try this in the dark. That's always fun. Shocked to leave it dark, not out of myself. That's probably what happens too. Alright. There you go, there's the light bulbs on. And the fan's still turning. One thing to note, you saw when I pulled off of that fluorescent bulb got just a little bit brighter there for a second. The thing about pulsing these transformers is you can use any. It doesn't matter what size transformer it is, whatever. You can use any of them. Pulse DC on those transformers. When you first, basically you first put your power to it, it creates like an electromagnet. Well, when you pull that off, let me show you. See if you can see this. Watch real close on this. Anyway, it's not cooperating with me at the moment. But when you pull this off, you'll see a really good sized spark coming off of there. That's when that field is collapsing on that doggone coil. And at that time, that's when the power is the strongest. And that's usually about the time whenever I'm touching something I shouldn't be. And I get the dog snot shocked out of myself. So, what you actually want is to be able to capture that energy when you break the circuit at that time. See, right now there's no capacitors involved in this situation. Now, if I put some capacitors strategically in there, when the circuit is broke, like this little arm going up and down, you can see that spark going on there. Every time you see one of those sparks is when it's pulling off on one side or the other. Well, as soon as that thing pulls off, which drops the power to this, it releases the charge in that you see that arc. Now, at certain points when I'm running this and I got it tuned right, you can literally see little flaming arcs on there pulling off because the power buildup in that coil is pretty amazing. There are like rectifier diodes, not rectifier diodes, they're flyback diodes that they use because of this particular deal to keep circuits from being damaged. And so my theory is that if you take and design a system with these, like you see right here, that you could capture that collapse every time, charging up a bank, and then be able to use that energy real time. And so, you know, with that said, the important thing to note here, right here, is like I said on this side over here, that's not a it's not a tight connection. You want that to be able to either do like this over here, where it's kind of vibrating and breaking, making and breaking that connection. Same thing is the reason why this tattoo gun works. When these coils magnetize, they pull that arm down and they'll go back and forth, which causes that arm to vibrate like that. But every time it makes and breaks that circuit, it releases a really strong pulse of energy. And if you are unfortunate enough to touch, like for example, when I was trying to tune it earlier, I put my hand here, my finger here to hold the deal, unscrewed this and touched that right there, and boy, I tell you what, I got lit up, man. That's what you think I got mad science hair for nothing? That's why, because stuff like that. But there's a lot of power in them coils and pulse DC whenever that field when you energize it the first time, when that field collapses, I mean, nature just slaps it back down and sends out a really high surge. And you could see from what I was doing there that it actually had some enough power to light this up at least part of the way, and still run that fan at the same exact time. And then this bulb, I don't know if you could see it or not, but it was still going. But once I took this off and that surge rushed in there in that bulb, it lit up brighter. So anyway, I'm going to see if I can get this doggone video mixed and get it up there for you guys to see. Peace and love. Stay tuned. I got some really cool stuff I'm working on.